inertial frame, and okay. So first, today we will just try to learn what is inertial frame. We will just try to see what are the basic notation and what is the basic mathematics in the inertial frame. And then tomorrow class, we will just go for a special theory of relativity, that is STR. This is just a relativity, okay, not a general theory. So general theory is entirely different. We are just talking about a special theory. The first topic is all about, most important thing is Lorentz transformation. And then we will learn all about relative speed. And once we learn the Lorentz transformation and relative speed, then we can go for application of this Lorentz transformation. The first application is length contraction. The second is all about time dilation. And third is all about loss of simultaneity. And then we will move towards mass energy equivalence. Where we will learn relativistic mass and all about the theory of mass and energy. Okay. So we will just try to learn all about the relativistic mass, relativistic energy, relativistic mass, relativistic energy, relativistic momentum. And then we will try to learn some collision problem, some different type of decay problem based on conservation of energy and momentum. Conservation of energy and momentum. And after then, we will try to generalize all the thing with the method of 4 vectors. So we will try to learn entirely different type of mathematics. We will try to generalize all this thing. We will learn 4 vectors, and then we will go for Doppler effect. Doppler's effect of light. Now, and as well as we will also learn little bit of Minkowski space. And this thing we will cover into the classical mechanics part. The separate topic is relativistic electrodynamics. Electrodynamics. This is your separate topics for the electromagnetic theory. So I will cover that part when we will go for electrodynamics, and then relativistic quantum mechanics. This part we are going to cover onto in the relativistic quantum mechanics. But and obviously in all the examination, this topic is there. So this is not mainly for JAM and JAM examination, but for NET examination, GATE examination, TIFR, JEST, everywhere, everything can be there. So you have to just prepare according to your syllabus and according to your need. Okay. So this is all about the course structure. Okay. So let's try to start the first topic, that is inertial frame. Okay. So before I am just going to start, if you have any doubt, you can just ask me. And this topic is in a modern physics for IIT-JAM examination. In a classical mechanics, for NET and GATE examination. Okay. So just try to see according to your syllabus. See the booklet according to your syllabus. Okay. Huh. And in the every examination, at least 2 questions will be there, and more than 2 can be also there. If you will count from the relativistic electrodynamics and relativistic quantum mechanics, then more than 2 can be there. But if you are just restricting yourself only for the STR, mainly the Lorentz transformation and relativistic energy and mass, then obviously at least 2 questions will be every year into every examination. Okay. And the best part of this topic is that this is very conceptual, very conceptual. So once you will able to build this particular concept, there is no need to do lot of practice and lot of calculation. The calculation is just algebraic calculation, sum, division, this type of calculation is there, arithmetic calculation mainly, and concept. But yes, concept is very, very deep rooted concept. So you have to work this topic in a very nice way. Anyway, now if you want to ask anything so that I can start. Everybody is comfortable? Okay. So let me ask you this particular problem. What is inertial frame? What is inertial frame? First, before going to frame, let me ask you, what is actually frame? Inertial frame to baad mein hogi. What is your frame? What do you mean by frame? If I am talking about a frame, what do you mean by it? Anyone?
Sir, a reference
Coordinate
axis
system.
used.
Frame means what? Some type of coordinate system. Exactly. So this is one type of coordinate system. And in general, we are taking what? Cartesian coordinate system. Okay. In general, we are talking about Cartesian coordinate system. So obviously, if I am saying a observer is on the rest frame of platform, means there is a hypothetical coordinate system is there, and observer is at the origin of that coordinate system which is attached to the platform. So whenever you are talking about frame or reference frame, you are actually talking about one type of coordinate system. And obviously, if you are talking about one type of coordinate system, that means you have to talk about origin and 3 main direction. And that direction is basically, I can say this is X, this is Y, this is Z. So this is your definition of frame. Whenever you are talking about frame, you are talking about coordinate system. Okay. Now, so this is one of the very fundamental thing. Now, what is meaning of movement? How can you perceive movement? How many frames you needed to define movement? Minimum how many frame you needed to define the movement? Is that single frame is enough?
Yes.
Single frame is enough?
No, sir.
So from only platform, how can you see the motion?
2 frames are needed.
So at least what you need to define the motion, you need 2 frames. Okay. What you need 2 frames. So suppose, and 2 frame attached to 2 different body. That is more important thing. So suppose you are talking about platform and train, that means one frame is associated to platform and another frame is associated to train. So the first frame, we can just name this particular frame is S frame. And so why? This is X, Y, Z. Any coordinate from S frame, we can say this is X, Y, and Z. The another frame, we can say that frame is basically S dash. So why? Its origin I can say O dash, and its direction I can say X dash, Y dash, Z dash. So whenever you are defining the motion, you have to define two frame. Now, is that frames are absolute or frames are relative if you are talking about motion?
Relative.
Relative. There is nothing called absolute frame if you are talking about motion. What is meaning of that? Meaning of that, if you are standing on platform, you can see your train is moving. And the observer who is standing on platform cannot see the platform is going to move. He will see only train is moving. So, but if you will see all the thing from the train point of view, or the observer who is sitting on a train, what he will see? He will see
Platform is
that
moving.
train is not going to move. But what is going to move? The platform is going to move. But the movement of that platform, he will see the actually in the opposite side, isn't it? So if I can say S dash is moving with respect to S in a I cap direction, so I can write velocity of S dash with respect to S is equal to V in I cap direction. Then I am also saying velocity of S with respect to S dash is what?
Minus V I cap.
So that value is minus V I cap direction. So if you have one information, suppose a train is moving with respect to platform, that means you have actually two information. One is an indirect information. The direct information is train is moving with respect to platform with some velocity. But the another information is the platform is also moving with the train with the exactly in a negative with the same magnitude but in negative direction. So there is nothing called absolute frame. So first thing we have to learn, there is nothing called absolute frame. There is nothing called absolute frame. The frames are always relative if we are talking about motion. You can never see absolute motion. If I am saying that train is moving with the 100 km per hour, that is not a correct statement. What I have to say, I have to say that train is moving with respect to earth or with respect to platform with the 100 km per hour. If we are changing the reference frame to the another train, then maybe this train is moving 50 km per hour. It will depend where is observer and what he want to see and what is his observation. So that will depend on what is the relative relationship between two frames. And this is the thing we have to learn. Okay. Now, so this is relative motion. So relative motion cannot be absolute. So motion is in fact always relative. So this is always a relative. If you are moving with respect to one frame, the other frame is also moving with respect to you. That's it. So you have to always remember this particular concept, and you have to use this concept in a very efficient way. We will learn the different type of symmetry when we will try to understand this type of system. Okay. Now, the first thing is that what is meaning of inertial frame? Anyone?
They follow Newton's law.
Sorry?
Follows the Newton's
Newton's
law.
law.
Obviously, they follows the Newton's law. That's okay. Means there is not any pseudo force. Okay. But in term of motion, can I say if frame is inertial, it is always moving with a constant velocity with respect to another frame?
Yes, sir.
Yes. नाउ अब जरा सोच करके मेरे को आंसर देना. सो इफ two frames are moving with constant relative velocity, then frames are inertial. The frames are inertial. Okay, then frames are inertial. So whenever I am talking about velocity, I am always talking about relative velocity. Either it is given or not given. Now I am making a statement and just try to tell that this statement is correct or false. If frames are inertial, it will always move in a straight line from the time minus infinity to plus infinity. The statement is correct or false?
False.
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 Why
False.
false? Why false?
Due to time dilation.
Due to time dilation. Here I am not talking about time dilation. I am not talking about anything. I am just talking about simple relative motion. What I am trying to say, listen, what I am trying to say, if two frames are inertial frame, they will always move in a straight line. The statement is correct or false?
Correct, sir.
True, sir.
Due to invariance
sir.
of
Yes, this is absolutely correct.
due to
Because
constant-
if you want to change the direction, then you have to give extra force on a frame, isn't it? Are you getting my point? If you are just moving a straight line and if you want to change the direction, something like this, then without using some external forces, you cannot change the direction. Even if magnitude of velocity can be same, but you have to give some force on the frame. You have to apply some force. So if I am talking about inertial frame, that means I am talking about the frame which is always moving in a straight line. That's it. Then only your frames can be inertial in nature. If they are moving, if they are changing their direction according to time, then obviously the frame cannot be inertial. The inertial frame means they have to move only in a straight line. So this is a very strong statement. And you have to always take care of this particular statement whenever you are trying to solve the problem. So means here I can say the inertial frame always moves in a straight line. I think you should appreciate this particular statement in a very nice way. Okay. Now,
Sir,
batao.
sir, Earth is inertial or non-inertial?
It will depends which type of motion you are considering. If you are considering that is motion is rotational motion, then it is non-inertial.
Yes,
Okay.
sir. Okay, sir.
So we are not considering it when we are solving the problem. We are not considering it is rotating or it is spinning. Okay.
So, but if we are taking motion around the sun,
Then it will be non-inertial because every time it is changing its direction.
okay, then it is no. Okay, sir.
Okay. Now, what is meaning of t is equal to 0? This is one of the very fundamental question you have to learn. You have to give the answer. Obviously, we are talking about motion. That means we are talking about two reference frame. We are talking about inertial frame, means the relative velocity between these two frames is just a constant velocity. They are moving in a straight line. So if they are moving in a straight line, that means suppose you have this frame and another frame is coming and it is just going to move like this. So what is meaning of t is equal to 0? This is very important.
origin sir.
Origin means what? Obviously तुम समझ रहे हो. Explain तो करो क्या है.
Dimension.
सर तब दो फ्रेम एक ओवरलैप करें.
Obviously, when the origin of two frames are going to overlap, that is actually t is equal to 0.
At coincide.
Yes, when the origin is going to coincide, then you are just talking about t is equal to 0. So at t is equal to 0, your s and s dash, the origin is going to coincide. This is the scenario at t is equal to 0. Okay, this is scenario at t is equal to 0. Now we will try to see the relationship between position and velocity from two frame. Now we will try to go for a very interesting thing, that is what? Galilean transformation. So let's try to go for Galilean transformation. यहाँ तक कुछ पूछना है तो आप पूछ सकते हो, because this is just a simple definition. So I don't think यहाँ बहुत ज़्यादा questions हो सकते हैं. But yes, you have to take all these assumptions when you are trying to learn a special theory of relativity. Everyone is comfortable?
Yes, sir.
Yes sir.
Okay, good. Chalo. So let's try to see the relationship between. So we will just try to learn a little bit of Galilean transformation. What is this Galilean transformation? This is very interesting. What we have at some time t, we have scenario of this two frame. One is S frame, another is what? S dash frame. And we have S dash is moving with respect to S with velocity v in I cap direction. Why I have chosen I cap? Who will decide what is your I cap, what is your J cap?
We will decide.
We will decide. Exactly. So hence it is just, hence inertial frame will always move in a straight line. It is very smart to decide that, okay, it is just coinciding with my I cap direction. Isn't it? Okay. Now, so this is my origin O. This is my origin O dash. This is my X dash. This is my X. And velocity of S dash with respect to S is V in I cap direction. That means I have also this information. Velocity of S dash with respect to S is minus V in I cap direction. So if I have this information, automatically I am getting this information. So it is exam में ऐसा थोड़ी देगा कि ये भी देगा या ये भी देगा. They will just give you one information, but when you are trying to solve the problem, you can take another information in a very trivial way. Okay.
So
Now look at,
velocity
yes.
S dash आएगा ना second में.
Sorry.
S.
Sorry,
at
S
second.
versus, okay, sorry. Thank you. S with respect to S dash. Yes. Good. Thank you. Okay. Now, there is a point in a space. एक point है space में जिसे आप P point कहते हो. Any point in a space you can just see. And this is your P point. And this point can be coordinated with respect to S frame is X, Y, Z after time T. What is meaning of after time T? What will happen before time T? That these two origin is going to what? Coincide. isn't it? So after time t of the coincide, we have this sort of scenario. This is x, y, z from S frame, and this thing is x dash, y dash, z dash from S dash frame. The same point can be coordinated, that is x, y, z from the S frame, and the same point can be coordinated with respect to origin O dash, and this is x dash, y dash, z dash, and which will nothing but what? S dash. Now, what is distance between these two origin?
VT.
V into t. Very good. So this distance is V into t. Now, what is this distance? X. What is this distance? X dash. Yes. So from here, we can write x is equal to x dash plus Vt. Everyone is comfortable? Now look at the symmetry. This is very simple, and this is nothing but identified as inverse Galilean transformation. Okay. Now you can also write this thing as, अगर मैं x dash को x के term में लिखूं तो क्या लिखूंगा?
X
Anyone?
minus VT.
Obviously, you will write x minus Vt, but I will not write x minus Vt. What I will write? X plus minus V into t. Why? This is very important. Because I just want to see the symmetry. This is very important. The getting answer is different thing, and visualizing the physics is entirely different thing. Now look at, this is nothing but the distance of point P with respect to S, isn't it? And this is nothing. What is this point?
C dash.
Distance of point P with respect to S dash plus what is V? What is V? Velocity of S dash with respect to S into time t. Now, if I am going to change S to S dash, everything is going to change. है ना? But symmetry will remain same. Now look at what is going to happen. D P with respect to S dash, we are just going to change S to S dash, and what will happen? What I can write this thing? D P with respect to S
With respect to S.
plus yes, V with respect to S and S dash and T. Now look at, now you can say only there is nothing called absolute frame. Yes, there nothing called absolute frame. क्या S है, क्या S dash है, उससे हमें कोई खास फर्क नहीं पड़ता, because I preserve my symmetry, isn't it? Look at here. If I am changing S to S dash, everything is going to change, but symmetry will remain same. This is very interesting transformation, and there is two transformation. This transformation is very famously known as Galilean transformation, and this transformation is known as inverse Galilean transformation. And this transformation is basically linear between x and x dash as well as x and t. So hence their linear transformation. You can jump from one frame to the another frame by just changing the sign of V, isn't it? बाकी सारा चीज क्या है? लगभग सेम है. If आपको S से S dash पर jump कर रहे हो, what is going to happen? Only you are just going to change this one, so the sign is going to change. So you can jump from one frame to another frame or another frame to first frame just by the changing the sign of V, and this thing is going to work. And look at this beautiful transformation. This beautiful transformation is all about the linear transformation. They are linear in X as well as linear in time. This is happening because your frame is moving with the constant relative speed. If they are not moving with the constant relative speed, then obviously this transformation may not be linear. And if your transformation is not linear, then you cannot have this sort of privileges that you can get from one transformation to inverse one by thus changing the sign of V. This is very, very important. आपको अभी लग रहा होगा कि यार ये सब तो सब पता है, it's okay. But yes, this is the actual thing. We have to work in a very efficient way. Everyone is comfortable?
Yes, sir.
Okay. Now let's move this story into next phase. अब हम क्या कर रहे हैं? Let's go for just for the next phase. What is going to happen? This point P is also moving with respect to S. Then this point P will also move with respect to S dash, isn't it?
Yes.
Okay. So what is this point P? Let's say this speed is ux or its velocity is ux, ui, uz with respect to S. Then the same velocity of this point, the velocity of this point with respect to origin O dash is equal to ux dash, ui dash, uj dash with respect to S dash frame. Now, what I have to do, we have to just write the relationship between ux and ux dash. And obviously, there is no need to write in a y direction because there is not any relative speed in a y direction. So y dash will remain same. But yes, let's try to go for our next definition. By the way, what is ux? How you will define ux? What is ux? That is dx by dt. What is your ui? Obviously, dy upon dt. What is your uz? dz upon dt. Now, what is your ux dash?
dx prime by
dx dash by dt.
dx dash by dt. What is your ui prime? That is dy prime upon dt. What is your uz prime? That is dz prime upon dt. So now we are just going to differentiate these two things. So what will happen when we are going to differentiate? Then dx upon dt is equal to dx dash upon dt plus v. And what will happen to this one? Dx dash upon dt is equal to dx upon dt plus minus v. Now, what is dx upon dt? Is ux. This is just ux dash plus v. What is ux? This is nothing. Velocity of a particle with respect to S frame is equal to velocity of a particle with respect to S dash plus velocity of S dash with respect to S. The same idea we can execute here also. So velocity of a particle with respect to S dash is equal to velocity of particle with respect to S. So here I can change S to S dash, velocity of S with respect to S dash. Look at this thing is the magical. This is magical thing. So this is very interesting and very efficient also. Now, let's create a story to develop an interest actually, and then we will learn why we are just going to need a special theory of relativity. Okay, so just I am making one very simple story. Let's work on that story, and then we can work for the special theory of relativity. Okay, yahan tak clear hai na? And now look at the symmetry. This is very interesting. This is very interesting. So why we cannot say there is nothing called, we can say that there is nothing called absolute frame. There is nothing called absolute frame. Frames are always relative. So what you are going to observe depends on which frame you are going to attach with. And this is the whole story talking about this particular, the relationship between inertial frame, isn't it? Now, let's try to go for a simple story. यहाँ तक clear है ना? Everyone? Okay. So now look at what is going to happen. Don't worry. Just we are taking this very simple story. So there is a train. This train is moving with velocity Vt. I'm deliberately writing this Vt with respect to platform. And there is a one observer on a platform. There is another observer on a train. This observer is rest with respect to platform, and this observer is rest with respect to train. So let's say this observer is, let's say this is X, this is Y. Okay, and you can assume this is some person and this is some another person. Okay, so you have two observer. So velocity of train with respect to platform is given Vt, and I can assume this is in I cap direction. Okay, you can assume that Y have some toy train. You can assume this Y is some child and it has some toy train. What is toy train? You have some this kind of simple train or simple toy car or simple car is there. Okay, and this car can move only in X direction. So Y is going to measure this car with velocity u1 into I cap direction. Y is going to measure this car with velocity u1 in I cap direction. Then Y is just calling to X and he is just asking what will be velocity of this car with respect to you. Okay, maybe he is some child, he is his uncle, and child is going and he just asking this question that with respect to me, this car is moving with velocity u1 in I cap direction. What will be velocity of this car with respect to you? Then uncle know how to apply Galilean transformation. What he say? Okay, I will keep myself on a S frame. उन्होंने अपने आप को क्या कह दिया? S frame को कह दिया. He just keep himself as a S frame. And what he say? He say this train is something like S dash frame. I will also tell you how you can define S frame, how you can define S dash frame. It's just of a matter of concept. So this train is S dash frame. So velocity of S dash with respect to S क्या दिया हुआ है?
VT.
Vt. So this is V and this is what? Vt. in I cap direction, है ना? Now, velocity of toy train, this is your, or train लिख दिया, of car लिख देता हूं, है ना? Velocity of car with respect to train, that is equivalent to velocity of car with respect to s dash, isn't it? What is this one?
U1.
U in
One
I cap
I cap.
direction.
U1 I cap direction, isn't it? Now, what we have to calculate? We have to calculate velocity of car with respect to platform. That means we have to calculate velocity of car with respect to S frame. यही calculate करना है ना?
Yes, sir.
Yes. So I can use this concept. So you can write velocity of car with respect to platform or with respect to S frame is equal to velocity of car with respect to S dash plus velocity of S dash with respect to S. यही तो use करोगे? Look at, I am just using this thing. Only P is changing to C. Now, what will we answer? What is velocity of C with respect to S dash? U1.
U1 I cap.
And that is, everything is in I cap direction. So U1, and what is this one? VT,
CT.
VT. So what will happen? This person X will see this car is moving with velocity V1 plus VT. The velocity of a car plus velocity of a train. He will just see this one is the speed. And obviously, this one is the correct one. Now, where problem arises? Look at here. What will happen when this car is replaced by a laser gun? Suppose I am going to change this car, और इस कार से हम लोग क्या निकाल लिया? इस बच्चे के पास क्या है? You have one laser gun. And there is a light pulse is emerging from this particular laser gun. What will be the speed of light pulse? C. And what is this particular C? This C is nothing but 3 into 10 to the power 8 meter per second. Now, this person measured this light pulse is moving with the speed of light, that is C. He is again asking this person, what will be this speed of light with respect to you? If this person is going to use Galilean transformation, and this is nothing but the speed of light pulse. So what we have to do? Again, we have to formulate this particular thing. Now, you can see. Velocity of a train with respect to platform is basically Vt. This is nothing, velocity of S dash with respect to S. Yes. Velocity of a light with respect to train is what? क्या है ये?
C.
C. Obviously, this is moving in I cap direction. What we have to do? We have to calculate, and this is nothing but equivalent to velocity of a light with respect to S dash, isn't it? Because train is nothing but what? S dash. Now, what will be velocity of a light with respect to platform? And what is my platform? Platform is my S frame. So we have to calculate velocity of light with respect to S. So again, we have to write the same equation. So velocity of a light with respect to S is equal to velocity of a light with respect to S dash plus velocity of S dash with respect to S. है ना? What is velocity of a light with respect to S dash?
C.
C. What will velocity of S dash with respect to S?
VT.
Vt. So if this person X will use the Galilean transformation for the light, what he will get? He will get speed of light is more than c. Isn't it? This is not correct. Are you getting my point? This is not correct. Why? There is one experiment. That experiment is Michelson-Morley experiment, which reveals that speed of light, speed means I am talking about the magnitude, the speed of light is not changing with respect to any inertial frame. Means either you can see this light pulse from the respect of train or with respect to platform, you have to always calculate the same speed c. And so why this is wrong answer, because it is not matching with the experiment, it is not going to match with the observation, and this will make a huge change into the working of physics, and that change is nothing but a special theory of relativity. Now everyone is going to understand.
Yes.
If you have any doubt, you can just ask me. I have just made the background why we need a special theory of relativity, and tomorrow we will do some little problem with Galilean transformation. We will just learn how to take S frame, how to take S dash frame. This is very confusing. So we have to make one methodology, how to make S frame, how to make S dash frame, and then we will try to solve one or two problems with the Galilean, and then we will move towards a postulates of a special theory of relativity, and then we will try to derive Lorentz transformation. Okay, so this is the main target for tomorrow's class. Okay, this is the first class for any topic. Will be always a very simple one, concept simple, but it is very important that you can make you can build the concept basis of all these assumptions and definition. Okay, by the way, आज की पूरी क्लास में हमने सबसे पहले क्या डिफाइन किया था?
Frame.
एस फ्रेम, अब फ्रेम नहीं एस फ्रेम, ठीक है ना? उसके बाद क्या डिफाइन किया था? एस डैश फ्रेम, और उसके बाद पॉइंट पी का वेलोसिटी डिफाइन किया था ना?
Yes.
So whenever we will solve any problem, first we will define S frame, then we will define S dash frame, and then we will define P frame. What is your point P and how it is moving? किसी भी हर problem को, what is the real challenge? Real challenge is that we have to solve each and every problem with the same method. This is real challenge. और ये देखते हैं हम लोग इसे कर पाते हैं या नहीं. Okay? So this is your first class. So हम लोग कल की क्लास में इसे और भी एक्सप्लोर करने की कोशिश करेंगे. Okay? Thank you.
Thank you, sir.
Thank you, sir.
Thank you.